So good afternoon, everybody. My name is Husain Hameed. In the era of 5G, I am a telecom engineer in Ericsson, and I just recently was involved in deploying 5G in Bahrain, so I was busy with that. And today I'm going to present for you part of a research paper which I am planning to publish soon with the help of my supervisors, Professor Hameed and Dr. Husain Hameed. So that part has this title, which you can see here, are spoofing detection for IoT networks using neural networks. Before I start, I would like to explain 4 concepts. The first concept is IoT, or Internet of Things. So how many of you has a mobile phone, a smart mobile phone? Everyone. Very good. Who doesn't have them? Okay, how many of you have a smartwatch? Smartwatch? 2? Okay, how many of you has a smart TV? Oh, yeah. That's good. All of these devices are IoT devices, examples of IoT devices. So anything that is connected to the internet is an example of IoT, or Internet of Things. So second concept is artificial intelligence. Artificial intelligence is the ability of machines to perform human-like tasks. What do I mean by this? Is that maybe you heard about Google Voice or Apple Siri. You speak to Apple Siri or Google Voice and you say, hello. You don't expect the answer to be, I am fine, thank you. And when you say, how are you, you don't expect the answer to be hello. So that smartness or that intelligence in the software to understand and recognize the voice and reply with the appropriate answer, this is called artificial intelligence. So that's the second concept. Third concept, today if I give you any device or any tool, like for example this one, and I tell you, I want you to learn how to use it. What you will do, some of you will go, for example, to YouTube and will try to just watch a video and see how it works. Those are visual learners. Some of you just will try to play with it and see how it works, and those are kinesthetic learners. And some will go to read the manual. We'll see how this works, and then we'll try to use it. So these different approaches, same we need to use for the machines to learn. So there are approaches and there are methods for the machine to learn. These algorithms, these methods are forming the field of machine learning. Artificial neural network, which I'm going to talk about today, is one of these approaches or one of these methods. That's fine, clear? We set the scene. Let's go to the next slide. Why I chose that field to do my research in? It's because of its importance. Here I'm putting some evidences of how important is this topic. The first one is the Gartner. Which are like just published in 2020, the trends or the technology trends for 2020, and they mentioned the use of artificial intelligence in securing devices or in security. The second thing is that just last year, the World Economic Forum announced UK and Bahrain as a test bed for a new artificial intelligence procurement rules. Another evidence is our leadership vision, and His Highness Khalid bin Hamad award for artificial intelligence is an evidence here. So that's my motivation. So as you just mentioned, who today is not using an IoT device? Every one of us. And tomorrow there will be more. It's expanding. Today is your watch, your mobile phone, your TV. Tomorrow it's going to be your car, your fridge, your shoes, the clothes that you wear. Everything is going to be connected to the internet. However, all those devices are not immune to attacks. So those devices can be attacked at any point of time and wherever you are. So for this research, we chose one type of attack, which is ARP spoofing, and we are going to test on it. So the objectives, what am I trying to achieve here? The first one is to review the existing literature regarding that topic of research. The second one is to propose a new approach or a new method using artificial intelligent neural networks in detecting ARP spoofing attacks. Related work. What does the existing literature say about this? So I have seen several researches, or the existing literature is recommending to use ARIMA for generic networks as a method to predict attacks. Where in artificial intelligence, where the literature review about artificial intelligence, it says that artificial neural networks can be used in traffic classification. So we have ARIMA that's good in predicting predicting attacks in generic networks, and we have artificial neural networks, which is being used for network classification. Like it says this traffic is for Instagram, this traffic for YouTube, this traffic for Snapchat, or those. So we took both of them, and we said we are going to compare them in detecting ARP spoofing attacks. Am I audible? Yeah, okay. Seems very quiet, yeah? Okay, so I decided to see what data I can use to test this. It's good. I'm lucky here that I found open source data, which is I'm citing here. This data was used in 2018, and it was put to the public to be used. Also, they made a research on this data in one of IEEE journals. So this data is in the forms of BCAP traces. So I took these BCAP traces, and then I just transferred them into CSV format, and then I filtered them I filtered these protocols, TCP, UDP, ARP, and I grouped them per minute. Okay, and I just flagged each minute if this is an attack or non-attack by putting 0 or 1. Then I applied the ARIMA prediction method. And this is what I got. If you see the line in red, it's the ARIMA predicted traffic, and this is the actual. So what I found here, that it is working on generic, it might be working on generic networks, as they said in the literature. However, using neural networks, I can see that there is huge difference, which goes up to 30 or 35% in some of the minutes. And this makes it difficult to say if there is an attack or no attack at any point of time. And this is due to the nature of the traffic for neural networks. It's a huge traffic, as well as it's unpredictable. So the behavior of the devices or the sensors, it's totally unpredictable. So I said, let's take this data, apply it on neural networks. So we have steps. First, we need to see which neural networks fits the best. And the best that was fitting for me here is the one which you can see is the one with the lowest mean square error. It's a neural network that had 3 input neurons, 1 hidden layer with 3 neurons, and 1 output layer. So this took around 2,500 iterations to be trained. And the good thing is that I got more than 90% here. 90% accuracy in detecting if there is attack or non-attack. So there is a conclusion here, is that ARP spoofing is one of the attacks that might attack our IoT devices. Second thing, when applying ARIMA, it had high error rate on the IoT networks. When applying artificial intelligent neural network, we could see that it has a more than 90% accuracy. So I consider this at least as a potential method or approach in securing IoT devices in the future. Thank you.